Let's say you have a cookie recipe that calls for baking powder. But oh no, you are out of baking powder. You dig through the pantry and find baking soda and cream of tartar. According to the internet, you can combine these to make baking powder. If we consider the span of these three ingredients, we could eliminate baking powder and not change the span. Think about it. If something's a combination of all three ingredients, just replace the baking powder with a combination of baking soda and cream of tartar. Baking powder is a linear combination of baking soda and cream of tartar. This means the set of the three vectors is linearly dependent, or one of the vectors can be written as a linear combination of the others. Formally, a set of vectors v1 to vk is linearly dependent if there are scalars c1 to ck, not all 0, so that c1v1 plus ckvk equals 0. This equation may not look like it equals 0, but subtract the baking powder to the other side. More importantly, a set of vectors v1 to vk is linearly independent if whenever c1v1 plus ckvk equals 0, then all the scalars c1 to ck equals 0. In other words, there is no way to write any vector v1 to vk as a linear combination of the others. Look at this condition. We've seen an equation like this before. This is a matrix equation. This says that if x equals 0 is the only solution to the equation ax equals 0, then the columns of A are linearly independent. Here's an example. Are the vectors v1 equals 1, 2, v2 equals minus 1, 3, and v3 equals 2, 1 linearly independent? We want to know if there are non-zero scalars so that c1v1 plus c2v2 plus c3v3 equals 0. Put each column in an augmented matrix with the solution column being all zeros. Reduce. We can already see there's a free variable, so there is a non-trivial solution to this system, and these vectors are linearly dependent. In the future, we won't actually need to work this problem. We have 3 vectors in 2 dimensions. That's too many vectors. In general, if you have k vectors in Rn, they are linearly dependent if k is larger than n. Notice this doesn't say anything if k is less than or equal to n. Be careful with that. Can you see linear dependence? Here's a graph with 2 vectors in R2. These 2 vectors are linearly dependent because they point in the same direction. One is a scalar multiple of the other. How about these 2 vectors? They must be linearly independent. Scaling one of the vectors won't change its direction. So for example, v1 cannot be a linear combination of v2 because it's not a scalar multiple of it. Finally, these 3 vectors in the plane. 3 vectors in 2 dimensions is too many vectors. They have to be linearly dependent.